Good morning, students. This lesson is of class 10th for the subject physics, topic calorimeter, its principle of method of mixtures and consequences of high specific heat capacity of water, which is covered in chapter 11, Calorimetry. And these topics are given on page number 265 to page number 267 of your textbook titled Concise Physics by Selena Publications and is being submitted to you on 7th December 2020. Let us start with our first topic, that is calorimeter. Students, a calorimeter is a cylindrical vessel which is used to measure the amount of heat gained or heat lost by a body when it is mixed with another body or a substance. Students, for reference, kindly see figure 11.1 given on page number 265 of your physics textbook. Students, a calorimeter is generally made up of a thin sheet of copper. Why it is made up of copper? It is made up of copper because copper is a very good conductor of heat. Copper is a good conductor of heat, and so the vessel made up of copper soon acquires the temperature of its contents. That is, whatever is the temperature of the mixture inside the vessel, the copper vessel will also have same temperature. So since it is a good conductor of heat, so the vessel made up of copper soon acquires the temperature of its contents. And second reason is copper has low specific heat capacity. The value of specific heat capacity, that is C, of copper is very less. So the amount of heat energy taken by the calorimeter itself from the contents to acquire its temperature is very small. That is, the vessel will have same temperature as that of mixture, and while doing so, copper needs a very less amount of heat energy from the mixture to attain that same temperature. So students, in case of calorimeter, it is made up of a cylinder, and the outer and inner surface of this vessel, it is polished so as to reduce the loss of heat due to radiation. Students, we have already learned in our previous classes about the transfer of heat, that is radiation, conduction, convection, and also we know about the process insulation. So all the four factors are kept in mind to make a calorimeter, and it is very important to know the reason for all these four elements. So students, the outer and inner surfaces of vessel are polished so as to reduce the loss of heat due to radiation. Students, if the surfaces are polished, there is less loss of heat because of radiation. Similarly, Now this copper vessel, which is polished from inside and outside, it is placed in a wooden jacket. That is, it is kept inside a wooden cuboidal block. And why wood is there? So as to provide insulation. Since wood is a good conductor or insulator? Yes, wood is a good insulator. So the calorimeter is kept inside a wooden jacket to provide it with insulation. And the space between the calorimeter and the wooden jacket. Now students, calorimeter was in cylindrical shape while the jacket is in cuboidal shape. So there will be certain amount of space left in between the jacket and the calorimeter. That space is filled with some poor conductor such as wool or cotton. Now this is done to avoid the heat loss by the method of conduction. Polishing was done to reduce the loss due to radiation. Wool and cotton is kept to avoid the heat loss by conduction. And the last part is, the cuboidal jacket is actually covered with a wooden lid to avoid the heat loss by convection. Students, in convection, hot air rises up. Remember? So, if that hot air rises up, it will come in atmosphere or the outer surroundings, which we don't want. So we want this outer air, the air going outside, to stay in calorimeter. So for that, we have placed a wooden lid to avoid the heat loss by convection. Now students, a very important topic, which is natural phenomena and consequences of high specific heat capacity of water. Students, the specific heat capacity of water is maximum, and you have to learn its value. Its SI unit value will be 4200 joule per kilogram Kelvin, or you can say 4200 joule per kilogram degree Celsius. Temperature can be written in any unit, Kelvin or degree Celsius. While if you convert kilogram into gram, it can be written as 4.2 joule per gram Kelvin. And if you want to write in calorie, then students, 4.2 joule means 1 calorie. So the specific heat capacity, that is C, the value of small c for water is 1 calorie per gram degree Celsius. So students, this is the maximum value of heat capacity, and due to this reason only, water is used as coolant and for many other purposes. So let us discuss some consequences of high specific heat capacity of water. So the first consequence is the climate near the seashore is moderate. That is, it is not so hot and it is not severely cold. So why so? The reason is again the same, that is, the specific heat of water is almost about 5 times as high as that of sand, and thus same mass of water requires more amount of heat to change its temperature by same amount. Students, we have done the formula of heat that is Q is equal to mc delta T. Specific heat of water is greater than sand. Now if we take same amount of mass and if we increase same temperature of both sand and water, heat energy taken by water will be more as compared to sand. So that is what I'm telling you, that as the specific heat capacity of water is 5 times high as that of sand, and thus same mass of water requires more amount of heat to change its temperature by same amount. While sand or earth gets heated or cooled more rapidly. Student, sand gets heated quickly and it gets colder also quickly. So the change in temperature of sand happens to be quickly as compared to water under the similar conditions. Thus, near the seashore, there becomes a large difference in temperature between land and sea, due to which convection air currents are set up. That is, if sea is warm, the hot air of the sea rises up while the cooler air from the land blows towards the sea. That is land breeze. And similarly, the cold air which blows from sea towards the land, known as sea breeze, it is formed only because of the large temperature difference between sea and sand. And that is also because there is a huge difference between specific heat capacity of water and sand. Similarly, second application of water is that water is used as an effective coolant. Students, in your car engine also, you might be knowing that we pour certain water which act as a coolant in an engine. Now, while driving a car, what happens? Because of usage of machinery, heat is generated in the engine, and that heat can cause damage to the engine. So we are having water flowing in pipes in the engine. And what does that water do? That water in pipes can extract heat from the surrounding, that is from the engine, and water in itself doesn't get heated quickly. So water in pipes can extract more heat from the surroundings without much rise in its own temperature, because it is having high specific heat capacity, which is 4200 joule per kilogram Kelvin. So thus water absorbs the heat of engine, making it cool, and there is very less change in temperature of water. Students, similarly, farmers fill their fields with water to protect the crops from the frost. So when there is very less temperature, what does the farmers do? The farmers fill their fields with water, and it is done for the protection of the crops. So in order to save the crop on very cold nights, farmers fill their fields with water, since water is having a high specific heat capacity. So it does not allow the temperature in the surrounding area of plants to fall up to 0 degree Celsius. So students, further kindly read all the other applications based on specific heat capacity of water given on page number 266 and 267 of your physics textbook. Coming to the further topic, that is some examples of high and low heat capacity. So students, now we have to study about heat capacity, that is C dash. The formula of C dash was C multiplied by mass M. So the base of a cooking pan is always made thick. Students, if you see a non-stick pan in your home or any other pan, you must see that the base of a cooking pan, even the cooker, if you are having a pressure cooker, the base of the pressure cooker is made thick. Now, why it is done so? Students, by making the base of a pan thicker, see its mass increases, and due to which its heat capacity also increases. So its heat capacity becomes large, due to which it gets heated very slowly and it can impart sufficient heat energy at a slow rate to the food for its proper cooking. And after the cooking is done, it can keep the food warmer for a long duration. Students, if you switch off the gas and the vegetable is in your pressure cooker, will that vegetable become instantly cold? No. The pressure cooker will keep it warmer for a longer time because the base of the pan or the cooker was thicker.